All right, let's do dummy coding. All right, for the past n number of sessions that we have, what we've had was an outcome that is continuous, right? And a predictor that are continuous. Whether it's one, whether it's many, all of them are continuous. And then let's rewind again. There's a method to the madness why we had in the very start of the semester talked about the levels of measurement, right? Because what you do depends on what the levels of measurements are, right? So in GLM, we have only one outcome, right? If you want multiple outcomes, you can go talk to Devin because that's an SEM problem. But for now, if you only have one outcome, and that outcome needs to be continuous. If it's other than that, if it's groups, right, or it's like this wonky data that you have that's not normally distributed, that's another issue. That's a generalized model thing. What we will discuss today is what if you have predictors that are groups? Because for the past several classes that we've had, we have been doing continuous predictors. So what we're going to be doing now, right? Because GLM is like this unifying way of thinking about data analysis, right? You're probably familiar with independent samples t-test, right? You're probably familiar with one-way ANOVA. You're probably familiar with two-way ANOVA because these are the things that Dr. Solosky have taught you. What we're going to do is to say we don't have to we don't have to know those things, or we don't have to use these things because we can do all of those things also in GLM, right? Because remember, with your ANOVA, you can only do like groups, but what if you have groups and other things, right? So again, GLM is this like unifying framework of data analysis, and that is what we're going to be doing. We are going to see how you can do ANOVAs and t-tests in a regression or a GLM format. So just to review, you still remember your equation of a line, right? And what it represents, how you would calculate for the expected score. We're still going to use that, right? We're just going to do a little bit of tweaks. All right, so just another review, right? We are in the general linear model, right? Which is again this unifying framework of data analysis. That has regression, but actually you can put t-test and ANOVA within this particular model. Like t-test and ANOVA is just a subset of really of GLM, right? So everything that we've learned so far is about the same. Now, if you have your SPSS open, and you have your exercise 6 dummy coding open, all right? If you look at, so if you want to do this, run from 13 to 37. Look, all of these things are the preliminary steps that we've been doing. Data cleaning, missing data analysis, list-wise deletion. These are all of the things that we've been doing, all right? So let's just run that. Okay, that should clean up your data. Again, from 13 all the way to 39. Okay. Now, if you look at 40, right? If you look at 40 all the way to 65, the first group of syntax that you see there, t-test, that's your t-test. That's the syntax for the t-test between groups t-test that Dr. Solosky has taught you, right? The second one is a two-group ANOVA, a one-way ANOVA that again, Dr. Solosky has taught you. Uni-ANOVA is another way. This is what we've been doing, right? Now, what are these three things for? These three things, if you run them, is me telling you that t-test is an ANOVA. An ANOVA is a GLM, right? So if you run the first group, you see that thing over there, that red, right? That's what you look at, right? Remember Dr. Salosky's class? This is what you look at. That's a t-test. T-test is only two groups, if you're going to compare two groups. Now, in our case, we're comparing males and females here, right? So, if you look at Dr. Salosky's class, is there a significant difference between males and females? Point 0.001, less than 0.001. Yes, right? If I ran the same thing with ANOVA, I am going to get this F over here and this p-value. The p-value is less than 0.001. Is there a significant difference between males and females? Yes. See, here's the thing. A t-test, again, is just a subspecies of ANOVA. They're exactly the same. A t-test, or if you run an ANOVA with two groups, that's automatically a t-test. So this is what annoys me the most, because they still keep teaching you t-test, when in fact ANOVA just does it, right? Because t-test is only two groups. You can only do two groups. If you have more than two groups, then you have to move to ANOVA. Well, why wouldn't you just do an ANOVA? They're the same thing. And in fact, if you have that t, you square that, it's going to be equivalent to your f. So your t-test is just an ANOVA with two groups. Okay, with me on that one? Right. Okay. So that's why, and then this is now our uni ANOVA. This is our GLM. If you look at that F here, same as that F here. We can do categorical. In the olden days, they would say that, oh, if you have predictors that are continuous and if you have outcomes that are, or one outcome that is continuous, you can only run regression on that one. But if you have groups as your predictor and you have one outcome that is continuous, then you have to run an ANOVA there. Look, no, right? Under GLM, no. We can do everything under GLM. But there's a specific way that you have to do it. Okay. With me so far on that one? So t-test is an ANOVA, and you can do an ANOVA under a GLM. The same thing. All right. Let's go back to the research question on this one, right? Before, our research question was, right, is impulsivity associated with audit? Remember that? Is alexithymia associated with, right? We're still going to do the exact same thing, right? Is gender associated, right? With what? We are now just still the same thing, that those groups, your inclusion in that group is causing you, it's causing your outcome variable, right? You being a male or a female is causing you to have this particular audit score. But we have to be more precise in our wordings here, all right? We have to be more precise in our wordings. Yes, the idea is still predicting. Yes, to some extent, it's still associative. But the terminology is now in mean difference form, right? That this group is going to have a significantly higher or lower scores compared to group B, right? Remember your activity with the papers, which, by the way, the feedback's going to come very soon. Remember that when I told you, oh, it has to be, is this higher or this lower? Does that make sense? Your categorical hypothesis, because that is how you should frame it. That's how you would write it, right? So when you're writing your research questions, when you're writing your hypothesis, yes, it's an association. Yes, we are predicting, but the terminology is we expect males to have a significantly higher mean scores compared to females, right? Okay, questions with this?
Is that one in the worksheet 4 that was telling us about four alternate hypotheses? And there's one particular one that did not show um, significance or direction, so it was marked as 0.
In a worksheet?
Yes,
Which worksheet is that?
that's worksheet 4.
Which is talking about what?
Core alternatives. Core alternate hypotheses. There were like 5 questions. Oh no.
Dabu, I can't remember. In the break or after class, show it to me so I can explain it to you further. Because I can't, top of my head, I can't remember. All right, anything else? Yeah. Why is it yelling at you? Subcommand, an unknown, check if it's pointing to your data set. Yeah? Don't. It's fine. Don't change anything in the data. Yeah, so exit and then open it again, then run it again. And let's see. If it's still yelling, let me know. All right, since we're doing GLM, there are the steps. If you remember, 1 is univariate descriptive statistics. Check your missingness, clean it, right? Next is step 2. Before, when we had continuous predictor, we would think about, do I need to center, right? Is my 0 meaningful? Would it make sense if I center? Where am I going to center at? Is that the mean, right? Or is that a specific constant that I like? In our case right now, if we have a categorical variable, right, you have to decide on a reference group. What's that? What's the reference group? What's it for? We'll get to that later, right? But you have to decide on your reference group and the type of coding, which in our case, we'll just be doing dummy coding for this class. The step 3, right, is you need to examine the bivariate correlations. Now, because we don't have correlations, because we have categorical, then you do an ANOVA for each of your groups, right? Remember your paper, right? The first group of papers that you have, I ask you to do an ANOVA if it's applicable for your categorical variables. This is the reason why, okay? Step 4, look for multicollinearity. Probably not that pertinent in our case. And then you decide, do I do simultaneous or do I do hierarchical? Okay, so it's the same thing. The only difference that we're doing right now is we are going to be recoding our group variables so that it becomes a dummy code so that the GLM can understand what it is that we're doing, right? So the only thing that we're doing is recoding, trying to make a different variable. Okay. So in our case, we're still using the same data that we have, right? It's still the audit that is going to be our our outcome variable. But now we will look at groups. One group that we can look at is gender, right? In my case, in my data, my gender has been coded 1 for males, 2 for females. Have you encountered this in your advisor's data set? Have you done this in your data set? Right? No? Like, how would you code whether or not they're males or females? 1 or 0. Same. And that's the thing about categorical nominal variables, right? It doesn't matter how you would do that. The number is just a representation of which group you are, right? So you can do 0 for males or 0 for females, 1 or 2. Hell, you can even do 7 or 6. It doesn't really matter. It's just a representation of what group you are in, All right. So let's look at, we will be looking at gender first, and then we will be looking at another group, three or more group. Now here's uh, let's test your hypothesizing. Alcohol use severity. Who do you think is going to have a higher, significantly, or a higher score? Males or females? Males. All right. So at least in the hypothesis, you hypothesize that men or males will have a significantly higher score compared to females, right? And that is what you're going to be testing with your data. All right. Remember, 1 is males, 2 is females, right? Dummy coding is just essentially recoding or creating more variables so that you can put that in a GLM equation. Okay. So very briefly, so we're going to repeat this again, but we'll start with how do you code your categorical variables. And here's are some easy steps, right? First, you need to know how many variables you're going to have, dummy variables that you're going to have. So moving ahead, right? What we're going to be doing is recoding and putting them in a different variable. A variable, again, in SPSS is a column, right? So you'll be creating a different column. Now, step number 1 is deciding how many variables, dummy variables, should I have. And the rule is G minus 1. Okay, so here's the thing. If I have a group, or if I have a grouping variable, males or females, how many groups do I have? All right, if you apply G minus 1, how many dummy codes should I have? Okay, if I have white, black, Asian, Hispanic, multiracial, 5 groups, how many variables should I have? Right? If I have a group, 1 is for low SES, 2 is for middle class, and 3 is for high class. Is it high class? Upper, right? How many variables should I have? How many dummy variables should I have?
I have a question.
2 variables. So we will be creating 2 variables. It's up to you, whatever you label it. Nope. We'll get to that later. I think I know what you're talking about, but let's talk about that. Dabu.
If we are minusing one among the 4, let's say there are 4, and we are minusing 1 because of the
Sure.
model. Among the 4, which one am I choosing to minus? So there's no preference.
We'll talk about that because you'll have to. I think that's step 2. You have to talk about the reference group. So hold on to your seats.
What is the dummy code?
A dummy code is a variable. If you're not getting it right now, let's move on a little bit, and hopefully it will make sense, right?
The column note, like what you're talking male, female, is your dummy code that column?
So you'll create a column, a variable. So if you have 2 males or females, that means you will only have 1 variable. If you have 5 groups, you would need to have 4 columns that you would recode or create 4 separate variables, right? Columns. Hold on, Holly.
That was kind of my question.
G is the number of groups in your variable. So if you say you have, so again, males or females, that's your group, right? How many are in that group, right? So group minus 1. So if you have high, low, or high, medium, low, you have 3 groups. Just minus 1, you need 2 columns, right? Okay.
Taking a step back, so but if we're applying the example, we phrase it as, is being male associated with higher scores?
You could. You could. But just for it to be clear, when you're proposing a hypothesis, you may as well stick with mean differences because that's what you're doing. So it's essentially like being male associated with, yeah, it's the same thing. It's just that for you to be clear so that nobody's going to yell at you. All right. Are we clear with step 1?
Yes, clear as mud.
Clear as mud? We'll get to that later. Only categorical. Again, categorical, nominal. Right? Anything else? All right. Hopefully it'll make sense. So Annalise, hold on to your seats. Hopefully it'll make sense later. But now we figured out how many columns and variables you need to do. Second one is you need to choose a reference group, right? So I think that goes to, I don't know if it's, Dabu's question, right? A reference group is going to be your point of comparison, right? This is going to be, everybody is going to be compared to this one. So if I have males or females, it's up to you who you want to pick as your reference group. But just be mindful that if you pick that reference group, it's everything, all the interpretation is going to be compared to that reference group, right? A reference group is your goalpost, is your reference group. Because that's the way that you can analyze the data, right? Because again, you need to do some comparisons, right? So you need to be comparing somebody with somebody, some group with another group. So you need to pick that one group first. Either, just pick one. So if I pick males, then essentially my new variable is going to be comparing to the reference group, which is males. If I make females as my reference group, then that means my results would say, the males is being compared to the females, right? So your reference group is like your goalpost. It's like if your data produces something, it's always going to be compared to that reference group, right? So pick that one, right? If you have low, I don't want to say low class, low middle class and then high SES, right? I could pick high SES. That means my data, my analysis is going to be low versus high and mid versus high. If this is still clear as mud, we'll get to that later. Just, get through the steps. I'm going to keep doing this over and over again. No, it doesn't have to, because your hypothesis is always a comparison against each other. So remember when I ask you in your paper, make all pairwise comparisons, right? I ask you to have a group that is more than 2, right? And then I ask you, put all the pairwise comparisons. This versus this, this versus this, this versus this. That's the ones you're doing. What we're doing as a reference group is a starting point for that comparison. Okay, so it doesn't matter who you pick, you're still going to have that pairwise comparison inevitably. Okay, anything else? Why?
We don't have the dummy coded variables.
There you go. Good. That's called troubleshooting or debugging. All right. Now for step 3, right? Remember, let's say I have 5 groups, right? And I will have 4 columns, right? Then you decide which ones are going to represent what, right? So if you have 2 groups, males and females, that's easy. I'm going to have males, for instance, as my reference group, and I only have 1 column. That column is going to represent females, right? If I have 3 groups, that means I will have 2 dummy codes, right? I pick a reference group. I pick my reference group to be low. That means I have to choose this low. So this means maybe I choose this group, this column here to represent the middle class, and I will choose this one to represent my high class, high SES. God, that sounds so awful. You get the idea? So these are the basic steps. How many groups do you have, right? Say 5. G minus 1, I need to have 4 columns. Which of the groups that I have is going to be my reference group? All right, I chose this one. All right, now I need to decide which of these columns is going to represent which of the groups, right? Hold on to that. Analyst, clear as mud, I get it. We will go through that one at a time. Okay, again. Okay, but if you are, that's fine. We're going to keep repeating this over and over again, right? I know it's kind of a hard concept to wrap your head around. All right, so let's do this again step by step. If I have two groups, how many dummy codes should I have? One, right? So I should only have one column, right? Let's say this is my one column over here. Now, next, you decide what your reference group. I decide that it's going to be males. It's up to you. You can flip it around. It's up to you. But how it is going to be coded as, what their scores are going to be, your reference group is going to be a 0. Your comparison group is always going to be a 1, right? I have one column that represents being female. With me so far? Okay. My intercept, my intercept points to my reference group. My new B points to my comparison group, right? Remember, we're always in comparison with each other. That is your expected score for your reference group, which is the males. This now is going to be the difference between your reference group and your comparison group. Right? We'll expand it more. Right? 3 groups. Right? 3 groups. Step by step. If I have 3 groups, how many columns should I have? 2. Awesome. We're getting there, right? Now choose your reference group. In my case, so by the way, you see this? A lot of your advisors or you would probably do something like this, right? You have just one column and then a number would represent this, another number would represent this, another number would represent this, right? For Hao Yung, how she did that was 0 and 1, right? So mine, it's 1 and 2, right? Okay, it's going back to this one. Choose a reference. Yeah. No, because you've automatically dummy coded yours, right? Unless you want to switch your reference group, then it's up to you. All right, if I have 3 groups, walk through this again. 3 groups, how many dummy codes should I have? How many dummy variables? 2, awesome. It's up to you what you pick. I pick low SES, right? That's my reference group. That means I will have 2 columns in my SPSS. With me on that one? I should have 2. My reference group should always be 0 on all of them. With me so far? Always, right? Let's say I have this particular variable that should represent the middle class. With me on that one? Then that should be a 1, right? Everybody else gets a 0, right? Okay. I would say that this column should represent the upper class. Everybody who's an upper class should get a 1. Everybody gets a 0. You get the rule so far? All right. Let's.
So as let's say, assuming I have up to 5 original codes, then it will follow a pattern. Like
Yes. You nailed it. All right. So going back to the equation of a line, that is the expected score of your reference group. This is the difference, comparison between your reference group and your first one, right? Take this away. This is now the difference between high SES and your reference group. Okay, another one. How about 4? Are you getting it so far? All right, now you have 4. I have 4 groups. How many columns should I have? Awesome, right? I choose, so let's say that's white, black, Hispanic, whatever. I choose white as my reference group, right? I have 3. I have 3 columns, right? The reference group should always be 0 on all the variable, right? I choose this column to represent the black. Everybody who's black should have a 1. Everybody else should be a 0, right? I choose this to represent Asians. all the Asians should get a 1, everybody gets a 0, right? I want this to represent Hispanic. All Hispanics get a 1, everybody gets a 0. Holly.
So my first question was, why do you not mix them up? But so basically, you have a column for every variable. It's like an easy way to look at it.
Mm-hmm. Mm-hmm. So again, for this one only represents a group, right? Yeah. Think about this as an on-off switch, right? So if you are black, then you get turned on, which is a 1. If you're not black, then you get turned off, which is a 0, right? Because this represents black. This represents Asian. So if you're not Asian, you get turned off, right? If you are Asian, you get turned on. Same thing with Hispanic, right? Okay, so going back to this one again. What's this again? Expected score of your reference group. How about this one? Ah, and you get the idea, right? All right, and then, okay. It's up to you what you want to title it. For our purpose, I just label it as either B1 and D1. Yeah, so.
Sorry, I understand this one, but when it's on SPSS, how would it look like?
We will get to the syntax later and how you would transform those things, right? We will see that later.
So you take white as your reference,
Mm-hmm.
and does that mean that they don't and they don't need it white and
Yeah, so the comparison that's going to happen if you're using this one, it's always going to be black versus white, Asian versus white, Hispanic versus white, right? Now, you might be thinking, well, what if I want to compare Hispanic versus Asian? We'll get to another step on that later. But right now, the way that the math works is that everything is being compared to your reference group. There's a way to cheat the equation of a line to get to these pairwise comparisons. But let's stick with this first. Everybody's being compared to your reference group. All right. How about this? You have 5 groups. 5 groups. How many should I have? 4. I would choose, just for shits and giggles, my first year as my reference group, right? Can you now imagine what the column should look like? All right, awesome. All right, with me on this one? All right. Now let's start with 2 groups, right? So let's do the analysis and let's do the 2 groups. Repeating over and over again, all right? If you're talking about a 2-group ANOVA, still the same, right? We would still have the same path model. We have gender predicting audit, right? I'm going to use men as my reference group. We've talked about this, right? Right? And then this one, right? Okay. Remember your dummy coding? Right? If I choose males to be my dummy code, then their score in that column should be 0. My comparison group should be 1. Yeah. So that it would fit into the equation of a line, right? So we can fit it into the equation of a line. And long story short, so that it could be analyzed properly. Now, let me tell you a story what would happen if you don't dummy code because it just doesn't make sense, right? I'm not going to name names, but there was this conference here. Maybe it was in Mackenzie, maybe not. A graduate student came in front and presented her wonderful statistics. But look, here's the thing, right? Here's the thing. In her data, she did ethnicity as white, black, this one. No dummy code. She just threw, so her data has something like this one, right? Something like this one. She threw it in her model, in her regression model. What is the interpretation of that? For every 1 unit increase of your ethnicity, remember what the slope is, right? For every 1 unit increase of your ethnicity, you increase, let's say, your audit score by 0.50. Does that fucking make sense? No, right? So I don't know if it was Devin or probably me because I'm the more assholey one. So the question was, how did you interpret your ethnicity? Is it how dark you are, right? As you increase your score, you get darker and darker. If I'm hungry, I, I'm a monumental dick. All right, but you get the idea, right? This is the reason why we need to dummy code these things, because if you plug it in as is, it just doesn't make sense because these are groups. If you increase the number, it doesn't mean that it just changes groups. No, you have to do it in a certain way so that it would capture distinctness of groups. Okay, yep.
So if you don't do the dummy code in this sense, like basically, if you're Hispanic, you're like up at 4.
I don't know how you're going to interpret that if you plug that in your.
I guess I'm just like, if it's everyone is 1, like that would be up 4. Like if the slope, never mind.
No, if you threw this in
Yeah,
1, 2, 3, 4.
Because it would be 4 instead of the 1.
No, if you threw this in literally in your regression equation, then that means, remember the interpretation for a slope, right? For every 1 unit increase in your predictor, you get an equivalent up or down change in your outcome. So if I move from white to black, does that make sense? As I increase it, it just doesn't. Yeah, am I turning more Hispanic? Reminds me of this song. I'm turning Japanese. I think I'm turning Japanese. I really think so. 80s. Or 80s. 80s babies here? No? Damn it. But you get the idea, right? So it's not, no, don't do that. All right? So, by the way, there are different ways of coding. Your readings have that. I put a link to the UCLA website that talks about different ways of coding. In our case, we are doing a dummy coding, but there are different ones. Just in case you get a boss in the future that prefers a specific type of coding, then that's going to be your go-to, because there's going to be a different interpretation for each. Like there's a grand mean centering coding kind of a thing. You can read that. For our case, you can survive with this one. Right, so a different one. All right, we're good with how you code it. Okay. And now let's analyze it. Okay, so let's do some analysis. So remember, our data, I'm going to put it here. I'm going to write it down. The mean score of males, right? The mean score of males, audit score of males is 7.22, right? The mean score of females is 4.80, right? The question is our males significantly higher than females? Okay. So let's go to this one. Okay. Dabu, this is how is that going to look like in SPSS? This is the coding syntax, the dummy coding syntax. If you look at this one, I'm just using recode, right? Because there's only 2. By the way, folks, I have there the exercise 6 dummy coding detailed guide I have you there my love letter on how to do the coding. It's a long-ish read, but it's a step by step on how to do these things. 2 groups, 3 groups, 4 groups, maybe 5 groups. Once you hit 5 groups, yeah, 5 groups. Once you have 5 groups, I hope that you already got the gist of what it's doing. Oh,
Say exercise 6, is that what you're talking about?
no. Exercise 6, dummy coding detailed guide, is my guide for you on how to do this. Like, these are different syntaxes for how many groups you may have.
Only need that then. We don't necessarily need to access that unless for our paper we need it. Like we don't need to access that for our homework.
I think for your homework, so your homework should have 2 parts.
Yeah.
The first part is more how do you dummy code these things, right? So if my reference group is a male, what would column 1 look like? Right? And then for the second part is a data analysis. Correct me if I'm wrong. I think you have a 2 groups there, and I think a 3 or a 4 group. So you need to know how to recode, dummy code, a 2 group or a 3 or 4 group, right? In order to do it, right? But I'm walking you through the syntax for this one. If you want something that's more detailed in explanation, exercise 6, dummy coding detailed guide. Because the way that we're doing right now in the other syntax is just more of, all right, this is the analysis in totality, right? This is the step by step. Here, it's more focused on the how do you dummy coding. Yes. Let's talk about that. I don't know when I'm going to finish, so I'm easy with that for that one. All right. So going back, how do you recode, right? Again, if I choose males as my reference group, I only have 1 column because G minus 1. If my participant is male, what number should that participant have? My reference group is a male. I only have 1 column. If a person in my data set is a male, what number should that person have? If a person in my data set is female, what number should she have? Awesome. This is what it does, right? So going back to the data, if you look at the data, that's my gender right there. It's 1 and it's 2. 1 for males, 2 for females, right? So ideally, if a person is 1, my new variable should have this as 0 and females as 1. So this is what it does. If you run that by the way is, oh, nope, not that one. This one, okay. If you run 71 to 76, okay. Yep, in exercise 6, dummy coding. If you run that, yes, then you should have a new variable at the end of that, and I named it gender dumb. Got it? Yes. Is it? Aren't you not at that space yet? Whenever shit just good happens, you just feel good, like holy shit.
So often when I get it done on my homework, I'm like, I'm actually
All right. So yeah, gender dumb, right? Remember, our reference group is males. Male should be 0. If you go back to the data, that's a 1. That should be a 0 in my new variable. Ta-da! Right? Let's go look at some females. All right, females, 2, right? 2, then in my new variable, they should be a 1. How young?
So on the syntax, it always what we need to.
Let me see. Oh, right. The sysmiss, what I'm doing there, the sysmiss equals sysmiss. What I'm doing there is if it's blank, just keep it blank.
That's what cismiss equals.
Mhm. If it's blank, just keep it blank. Now, you may have other things. I forgot whose that was. I want to say it was Holly, or I want to say it's Veronica's paper. I might be confusing this with another class. Wherein, oh no, maybe it was Caitlin. Caitlin's not here. You have males and females as your primary variable, but the way that she collected her data was male, female, intersex, and I forgot what the other one is, right? So let's say 1 and 2 for male and female, and then I don't want to include 3s and 4s because that's not, because we're in Texas and we, right? Those people don't exist. Shit, I'm recording this. I'm gonna get fired. All right, and then so what you do is 3 and 4, you make it as a sysmiss, right? So you make it blank. Yep.
So, sir, so on that new column for the gender job,
Mm-hmm.
0, 0, 0, 0,
Mm-hmm.
then 1, 1, 1, 1.
Yeah.
So anywhere we see 0 is for the reference.
Yeah.
Then
That.
anywhere we see alongside
Nah. 1. Wait, are you talking about them? Then those are females. These are males.
the question mark.
No, it's just not loading because I have a slow computer. Doug, I need a new computer. There you go. The ones? Yeah. Yeah. This one is just not loading properly because slow. All right. With me on that one? Yes. Um, no, you don't have to. Actually, that's sysmiss. If you did your cleaning properly, you can afford not to do that.
But it's not recruiting.
Yeah, it's not going to yell at you. It's not going to break your model or anything. But just always double check. That's my thing about that, right? Because sometimes, like for instance, in Caitlin's case, right, you have 1 and the 2. You don't know what the SPS is going to do with the 3s and the 4s. What are you going to do with that? Just always double check your data. You don't want to be producing wrong results. All right, cool with this? All right. Yeah, the t-test using GLM. All right. So this whole examine thing that you have is just a descriptive statistics, right? So we will look at the descriptive statistics and we will see that the mean of the males is 7.22. That's correct. And then the mean of the females is 7.80, rounded off, right? Okay. Again, 4.798 rounded off 4.80. Okie dokie. So now let's run our favorite Uni ANOVA, right? So if you look at the Uni ANOVA, it's the same thing that we've had before. You have our outcome, which is the audit total, and now we have our our dummy coded gender variable, right? This, folks, is essentially just a t-test, right? One outcome that is continuous, one predictor variable that is 2 groups. Save is the same thing that we've had before. Print is the same thing that we've had before. L matrix, I will get to that later, right? But if we run this, you will have the exact same thing that we've been looking at before. All right. So thing that you need to look at is the parameter estimates. Okay. Okay. Now, there is a slight tweak in our interpretation of one of the intercept, right? So what was the interpretation of the intercept before? It is the Expected score, outcome, mean, when all the predictors are at 0. Okay? Sorry? No, that's not an empty model. Empty model and whatever models that you have will always have an intercept. But the intercept is always the expected score when all the predictors are 0. Right? Okay. Remember this one? It only goes from 0 to 1. 0, 1. 0, 1. If this is 0, it's a male. If it's a 1, it's a female. Right? So if it is 0, right? Again, going back to the definition of intercept, the expected score when all of your predictors are 0. If this is 0, it's a male, right? So it's the expected score of the reference group. With me so far? Okay. Now, what is this now? It's the difference from the reference group, right? It's the females or whatever you put there. That's the difference of that group and the reference group. Okay, with me so far? Okay. Where does that show up? Okay. Where can we find it? Excellent question. Parameter estimates. Okay? Parameter estimates. Can you find the intercept? Yeah. Again, the intercept is the expected score when all my predictors are 0. In this case, I have only one predictor, and 0 represents males, 1 represents females. So, intercept is the expected, yes! Right? It's the same. Alex was pointing out, it's the same. Yes, it's the same because that is the mean score of the males. Now, what the hell now is the gender B, right? Remember, the B here is the difference between that group and the reference group. Yeah, it's the B1, that's the B1 right there, right? That is the difference if you move from being a male to being a female, right? If I'm a male, bad analogy, but ride with it. If I'm a male and I turn into a female, right? Will my score go up or go down? Down by how much? All right. So, if you have your calculators out there, 7.223 minus 2.425, you should end up with around 4.80. Plus minus because of our rounding error.
Right, so in this one, the B0 is the intercept, the 7.2 whatever.
Mm-hmm.
And then the B1 is the one below.
Yep. Okay. All that jumping around. I need to get fit. Now, is the difference between males and females significant? Right?
Yeah,
Everything that we've talked about before is the same, right? Okay. The parameter estimates, yes. That is where you find the slopes, right? So, again, that intercept pertains to the reference group, right? So that's this one, right? So, this one, right? Okay? So this is your equation of a line. So, I put here B0 or B0 plus B1 times 0, right? If you times something with 0, it becomes, so it's just B1. So that's 7.223, right? Equation of a line. B0 plus B1, you can only go 0 or 1 in the dummy code, right? So if you flip that, right? If you flip that on, then that becomes 1, right? So that becomes 7.222 plus Negative 2.425 times 1. Anything multiplied by 1 is what? Itself, right? So 7.22 minus 2.425, you end up with this one.
So that minus number in the difference, does it have a meaning or just for the subtraction?
This one?
Yeah.
That one is the slope. That tells you whether the slope goes up if it's positive, goes down if it's negative. So if you plug that in an equation of a line, this is the equation of a line, open close parentheses. If that's a negative, then that means you subtract it. Yep.
There's a B2, B2.
We're getting there. We're getting there. A step at a time. Yeah, we will go through this again. Okay, but you get the idea of the difference, right? You get the idea of the difference. So comparison group minus the reference group. Females mean versus males mean. You get that one. Because you need to understand this, folks, because we're getting now to our dreaded L matrix, right? Before, we were using the L matrix to compute the expected score, correct? Right. So fortunately, this time, your numbers can only go from 0 to 1. So yay, right? So Annalise is giving me that. All right, you got to explain this a little bit more. Sure. All right. Equation of a line, right? L matrix. L matrix is you're doing an equation of a line, right? Intercept, you only goes from 0 to 1 because you're turning it on and off, right? So the first line there that I've highlighted, this shows the expected score for males. That doesn't do anything. It's just a note to yourself. Intercept is a 1. My gender dump is a 0, right? Because it's males, right? The second line, this shows you the expected scores for females. If you look at that one, intercept 1 turned on, right? Gender dump turned on too, right? Because that signifies for females. With me so far? So you apply the equation of a line, you should get those things. Now the third one, what the F is that one, right? This is the difference between females and the males, right? So remember last time when we were talking about that negative 2 point something is the difference between males and females. That's just that. You're just turning on, but we don't have any intercept, right? Because you're telling them, just give me the difference between this group and then this group, right? That is that one.
It's like you would have already solved it.
Right, but there's a method to the madness to this one. Because remember, when we're adding more groups, Hao Yung's question earlier, because everything is compared to the reference group, right? Everything's being compared to the white, right? But what if I want to compare now, let's say Asians versus blacks, right? It doesn't. We don't have that in our output. We can get to that by doing the L matrix, right? So this last one, yeah. So this one, understanding this one is going to be the secret to that pairwise comparison later on. Right now, we only have one pairwise comparison, right? It's just males versus females, right? So, and that's that. Okay.
So this element is something
It's the same thing as doing the equation of a line manually. So that's why I keep hammering the equation of a line. You need to understand how to do the equation of a line because this is how you do an equation of a line if you don't want to compute it manually, right?
Have we already run this to see what it looks like in SPSS? Like all the L matrix
Yes.
stuff? We've already run
Yes. Yeah. So I haven't shown you that one. So the score for that one, and again, it's the same place where we have our usual one. So the first custom hypothesis, it's over there, right? 7.223. That looks familiar. Yeah, it's the intercept, right? Because you have intercept 1, dummy code 0, use your equation of a line, you end up with 7.22. Second custom hypothesis, 4.798. Oh my God, where did I encounter that? Well, that's the mean score of the females, right? You have your male score, your reference group. and then you add or subtract the slope, and then you end up with that one. And then the custom hypothesis 3 is the difference between males and females. Now, what's the difference between males and females?
Minus
Negative 2.425. That's the difference between males and females. So can you see, can you already envision later on how we're going to use this? Because we need to have the comparison between, let's say, blacks and Hispanics, right? Or blacks versus Asians. That is not in our original equation of a line. Is that a question, Dabu?
yes. So when interpreting the syntax of the L matrix on our output now, this is where we
That is where you would see the results. Custom hypothesis. And that's your L matrix, right?
why did it become KDF?
I don't know. Job security. I don't know the people who program that thing. That's how they do things. Yeah, there's a lot of things that I just doesn't make sense to me why they do it. A lot of it is about tradition. That's how they've been doing things. All right. 3 groups. We have time? 10 minutes. We have 3 groups. All right. I don't have a 3 group in my data set. So what I'm going to do is I'm going to use alexithymia, and I'm going to break them down into 3 groups. This is important. If you already have a continuous variable, don't break them down anymore. Right? No, bad. It's better if you already have a continuous variable, don't say that, oh, I'm going to turn them into low, medium, high. No, don't do that. Plug them as it is. Right? There's a lot of issues with that one. Just don't do it. I can tell you after class, if you just don't do it. But in this case, I don't have a 3 group. So what I'm going to do is I'm going to look at this alexithymia, and I'm just going to break them down into 3 groups. Right? So this is what I'm doing when I'm breaking them down, right? This is not the dummy code. I'm going to break them down. So what I'm doing here is I am going to recode my participants' scores. If they got a score in alexithymia from the smallest up until 51, they get a 0, right? And I'm labeling them as no alexithymia. If their scores are between 52 and 60, I'm going to give them a number of 1. I'm going to put them in number 1 in group 1, and I'm going to call them possible alexithymia. And if you have 61 up until whatever the highest number is, I am going to put you into group 2, and I'm going to call you the alexithymia group, right? And I'm doing this because I don't have a 3 group thing in my data. So if you may, let's run that. And now I should have a task group, right, at the end. So think about this as if it's like your low, medium, high, right, group. Okay, low, medium, high, alexithymia. All right. So this, folks, is the coding, is the dummy coding. Again, I am going to use my no alexithymia as my reference group. If I have 3 groups, how many dummy codes should I have? 2. Okay. The first one, I want to represent the medium alexithymia. The second one, I want to represent high alexithymia, right? Now you have this. What's going on here? It's do if. It's a do if statement. And you can translate this into English, right? It's like if you have a minion, this is how you would tell them, right? If you see this one, do this and this. If you see this one, do this and this. If you see this one, do this and this. And if, that's the end of my instruction, and you execute that, you little gnome. I'm just imagining it like you have like gnomes or dwarves as your servants. Anyway. Yes. All right, you get the idea? All right, so if you look at that one, I have dum1 and dum2. What's dum1 and dum2? That is now your 2 variables, your 2 columns. I am using dum1 as the representation of the medium alexithymia or possible alexithymia. I am using dum2 as the representation of the high alexithymia. With me so far? So if you look at this one, right, do if, hey, little gnome, if you see a score of 0, I want you to have a variable called dum1, and you put a 0 on it. And for my variable dum2, I want you to put a 0 on it, right? Because it's 0, 0. It's my reference group. Now, my dum1 is for my medium, right? So, if you see, I'm at the else if. So, if you see something that is a 1 in this variable, right, I want you to put a 1 on dum1 and a 0 on dum2, right? If you see a 2, I want you to put a 0 on dum1 and put a 1 on dum2. End of instructions, executed. Okay, with me on this one? All right, perfect. Now, this whole examine thing, again, is just descriptive statistics. So if I run that, I should end with the means of each group, right? So, you see that mean? I have the scores here. All right, I need to change that because that's not the task group. All right, task group mean. Yes, hold on. Yes, this one, the 131, it says males and females. That's a mistake. All right, it should be, where's that? All right, so no alexithymia. So no alexithymia, their score should be 5.51, right? Group 2, possible alexithymia, your mean should be what? 5.20. And for the severe or alexithymia, their score should be? All right. 5.406, 5.41, rounded off. All right. So we need to be able to go back to this means, right? Using the same idea. So this is our GLM, right? This is our GLM. Now look at that one, right? Audit total is our outcome with, and now you have dum1 and dum2. Those two variables are two dummy code variables, right? The design has these two things. All of the same things are the same. If you look at this one, we will go back again to this one, but if you look at these three things, this is just calculating. So the first three L matrix is just calculating for the mean, right? The mean score. This is now, so remember, everything is being compared to the reference group, right? So the dummy code that you have, the first dummy code that you have is between, it's a comparison between possible alexithymia versus no alexithymia, correct? The second dummy code that you have is a comparison between severe alexithymia and no alexithymia. What about the comparison between severe alexithymia and possible alexithymia? We don't have that. That is where you will get that. All right? So let's run this first. Yeah.
Assuming now I want to do a separate syntax and do what is the different data, and I have like let's say 5 group, meaning 4
For dummy code. So how many? So how many things should be after the with?
It should be done 1, 2, 3.
You said you have 5 groups.
4.
You have 4 groups.
Yes.
How many dummy codes should you have?
3.
Okay. What should be here?
3. Dom 1, dom 2, dom 3.
What should be here?
Dom 1, dom 2, dom 3.
Okay.
Then where that L matrix comes in. Yeah.
Yeah, so now you will have another one of these things, right? Because you have 4 groups, you said, right?
Yes.
So the intercept is for your reference group, right? Your second L matrix should be between the reference group and your second group. You have another L matrix that's going to be between the reference group and the second group, right? Or the third group. And then you will have another one that's between the reference group and the last group, right? Now you will have, so this last line over here is pairwise comparison. If you have 4 groups, all right, if you have 4 groups, everything is being compared against the reference group, right? So what about the pairwise differences between these 2 groups, right? So you will have how many pairwise comparisons? 1, 2, 3, right? So you will have 3 of these things.
You know why I'm asking? Sometimes I used to copy your syntax and
Oh, you
see
don't,
my
yeah, you don't copy it as it is. You got to think about it
yes,
as
yes.
well.
So when assuming now if I want to copy and I have up to 4, how would I change this?
You don't change it, you add it. You add one more line that's something like this, and then you change these things. You can change it, right? So you have this one, you have this one, you have this one, right? Because we have 3 groups. And then you have another one, copy and paste this particular line, and then you switch these things if you want to, right? And then you add another DOM3 for your in your case, right? Cool. It's 1:51. I gotta go. No, you gotta go.
Yes, sir.
All right.
So my
So
question, can I show you on
yes, after let me end class, and then we can talk about your. All right, I am done. Any other questions before we go? Probably not. Well, we can do it. We can push it. Well, let's decide next meeting on Thursday. So I don't know about them.
well, all IDA presented on
If not, then you guys can listen to to the recording from my previous class if you guys don't want to come to. Yeah, we're going to continue the dummy coding. Anything else before we go? Can I address Dabu's question? Going once, going twice? I wish.
Ponytail days.
Were you here when I had long hair?
I saw the
Yeah, you taught my 20.
the
oh, it
video,
was
the
gone?
YouTube
Okay.
video. Look,
No, 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 no.
yeah.
Just look up the faculty. His faculty picture on one of the websites still has long hair too. Oh wait, no, it's not a picture. It's a.
Yeah.
It's a video.
It's a video.
It's
Your
YouTube.
bio.
Yeah,
Yeah,
I saw it.
Yeah,
With a
it's-
ponytail.
So you know how the department.
Motherfucker, what are you talking about?
Department did like bio videos and all the professors like
Yeah.
tell us about yourself. Yours is still up.
Ah.
Yeah, it's glorious.
Yeah, I had COVID. COVID.
I drew it. I watched it when I was applying.
Yeah, that's what
All right, if you guys are done.
Yeah.
What?
Thank you. All right, those that have questions, be happy to answer them, unless you need to go.
Thank you.
All right,
Why is this not an alternate hypothesis?
it's not an alternate hypothesis because associate A is mostly for correlation, and B, it's not giving you direction, right? Because if you read the descriptions, it has directions in it.
Yes, it has.
Yep.
Okay, lack of direction.
Okay. Next, what else?
Yeah, that's what I'm working. The videos are helpful, and I'm getting to understand. Yeah, my problem is interpreting from the output. What? Yeah, but I'm working on
Okay.
it gradually. Yeah. So don't mind the video. I want to understand before I.
Sure. Yeah, and no pressure, right? So you have to
Thank you.